Hi, everyone. My name is Evan Yu, and I am the author of Vue.js. And today, I'm really happy to be here talking about Vue. So before we go into that, I just want to see a show of hands. How many of you have heard of Vue.js? Have used it? Use it very often? Great. All right. So almost all of you have heard about it, but I assume that a lot of you probably, just briefly learned about it or haven't really used it in depth. So I'm just trying to. This talk is going to be kind of high-level overview of all possible things that's going on in the Vue.js world, and if you are interested in more technical, like details of code samples and stuff, I did that in the Laracon US talk. So I believe the video is also online. So you're welcome to check that out. So this talk is there isn't going to be a lot of code. It's mostly talking about philosophies and existing features and things like that. So that's my Twitter handle, GitHub username. They're never the same and really hard to remember. And previously I worked at Google Creative Lab and Meteor, and now I'm working full-time on Vue.js. Working full-time on open source is awesome. And Vue.js itself, the project started back in late 2013. That was when I was still at Google, and it started as a really sketchy prototype. I was just trying to figure out how data binding worked in Angular, and ended up creating something with a similar syntax, but with a fundamentally different internal implementation. The first official release was in February 2014. That was, I believe, the 0.6 or something, and it took quite a while. The project release got several hundred stars in the first week on GitHub, and to me, back at that time, it was a huge success. I'm really happy about it, but it was still nothing more than just a small personal project. I didn't really think about Vue as something like I never imagined it would be growing so much to the scale of today. So back then, it was just a thing that I built, and I forgot about it. I put it out there, but people started using it, and more people started using it. And every time there was someone telling me, hey, this thing is great, I started putting a bit more time into it. And eventually, in April 2015, this happened. And after this tweet, this was the Google Trends about Vue.js. It was just exploded. And I was quite shocked, to be honest. So I'll be honest here. Before this tweet, I didn't know what Laravel was. But after this, I was like, wow, this is huge. All right. So today, Vue.js has 25,000 stars on GitHub, about 150 key downloads per month on NPM. That's not including CDN links. I think we just surpassed 1 million downloads just a week ago, and I also currently have around like $8,000 monthly support from the community, just to allowing me to work on it full time on open source, which is just unbelievable. Like, I never imagined this could happen. So, and that has a lot to do with the Laravel community. So thank you all for making this happen. Okay, so now let's talk about Vue itself. So Vue evolved along the way from a very simple small core library to kind of have its own ecosystem of surrounding tooling and libraries and all that. So in the beginning, I was reluctant to call it a framework because it was really just the Vue layer library. But today, there's a lot more into it. And I kept thinking about what makes Vue different from a huge monolithic framework that comes with everything out of the box, and why so many people seem to like Vue better than in comparison to those frameworks. And I came to the conclusion that Vue was designed from the ground up as a progressive framework. So we probably all heard of a progressive enhancement or a progressive web app, which is a concept Google's been pushing lately. But what is a progressive framework? So the word progressive is defined as happening or developing gradually or in stages. And I believe frameworks can be designed the same way, in that each step of the framework can be adopted incrementally. And the reason we need that, particularly in the front-end world, is because front-end has exploded in complexity in recent years. If you think about building a really large-scale front-end application, there are so many things involved. But at the same time, there's something fundamentally different between front-end and the back-end, because in back-end, you do a lot of similar things for almost every app. And you always need a user system. You almost always need a mail system. You almost always need a queue or jobs, things like that. So it makes sense to pack these all as a battery-included framework. But for the front end, there is a wildly varying level of complexity in terms of front end. Sometimes when you're building an app, it also has to do with the back-end framework you're using, right? If you are building an app that is primarily rendered on the server, you're just trying to add extra functionality, interactivity onto your front end, right? You probably wouldn't want to adopt a full-blown single-page application framework, but there are other times where you probably just need a little bit more power in handling that growing complexity. Or sometimes you do want to build a full-blown complex front-end application, right? There are different levels of needs when it comes to the front end. And it's important to have a solution that can have the elasticity to adapt to different complexity scenarios. And I believe Vue is headed towards that direction. And so I'm going to try to peel down all the things you would need to have in a complex front-end app, and try to peel down parts that you don't actually need in certain scenarios. And I believe at the very core of all modern front-end libraries is the ability to do declarative rendering. And we'll talk about the rest of them following that. So the fundamental problem we have when doing any type of front-end work is how to keep your client-side state in sync with the DOM, right? So it's easy when you're just rendering a static page that never changes. But when things start to change, it starts to get complicated. And what has changed is your client-side state. For example, you have a drop-down. It has a state of closed or open. And when it changes, you want the DOM to be changed accordingly. And it's easy when you try to do it when there's only one thing happening. So you can use jQuery, of course. You can just select the element, you can just set its display to none or display to block. But it all sounds easy at first, and then you gradually add more functionality into it. And you start having more and more complex selectors, and then you nest callbacks, things out of callbacks. And when you continue with that type of imperative DOM manipulation, you inevitably end up with something like this. Not saying that jQuery is bad, but it's just if you try to build a really complex app with jQuery, it's not going to be very maintainable. So what we really want is to have declarative and reactive rendering that makes everything more simple. So when we render things on the server, right, it's relatively simple because we are just pulling data and we render once. And it's idempotent. It doesn't change over time because every time a new request comes in, you're doing a new render. But when you are on the front end, it's a long session, right? So the user will be continually interacting with your app, and your app has a state that's continually changing. So you have this very difficult job of keeping your state in sync with the DOM. And the DOM has such a tedious APIs, which makes this even worse. So the state should be the single source of truth. And we want our DOM to we don't want to even touch the DOM. We just want the DOM to be the shape it should be, right? That's the ideal situation. So the goal of Vue is to make that happen. And when you write a template in Vue, we are declaratively telling Vue, say, hey, this is what the Vue should look like according to this state. And once you have set up that relationship, you just focus on manipulating the state instead of caring about touching the DOM yourself. So that frees us from this messy problem of trying to keep two things in sync with a terrible API. So now you can focus on just on the source of truth instead of something that you don't want to touch. Okay, so I believe Vue kind of solved that problem in a very minimal fashion. And what's more important is, on top of this, so when you try to do this, there's also a shortcut, like a hack you can do this with, is you just do inner HTML the whole thing. You know, render a string template, replace the whole thing every time, right? That's also really simple, but the problem is that that's going to be really expensive if your app is big, and also it throws away all the existing DOM nodes. So if the user has like focus state on input elements, it's just going to be interrupting the user experience. So that's not feasible. So we need some techniques of making that happen, and there are a lot of technical details in how different frameworks implement different strategies on efficiently updating the DOM. And I'm pretty proud that Vue is probably one of the fastest out there. So this is a 2.0 benchmark. We have a vanilla JavaScript implementation as the baseline, and Vue is only 1.29 times slower than the vanilla version. So lower is better here, and this is based on an independent third-party benchmark. I had nothing to do with it, so I'm pretty happy that someone actually spent the time to implement a very complex benchmark in all those frameworks. And if you're interested, the link in the slide links to a table of probably 15 to 20 different frameworks, all implementing the same benchmark. And more importantly, at the same time, it remains approachable. To get started with Vue, you don't have to first jump through how to set up Babel, Webpack, ES 2015, JSX. You just pull it in through a script tag, and you can start using it. The barrier of entry is intentionally kept minimal to make it maximally approachable, and we take great care in making sure that the onboarding experience for new devs is smooth, and so that they can become productive as fast as possible. So that's always going to be a focus of Vue. Okay, so once we have tackled the reactive rendering problem, the next thing you want to do is having a component system. The reason for that is, although we have managed to make the relationship between your state and the DOM relatively straightforward, the inherent complexity in your UI hasn't changed. If you have a huge UI with tons of content, you eventually need a way to break them up into more manageable units. And that's where components come in. And this component is not really something new. And when you think about it, almost all app UIs can be broken down into just nested components, nested boxes, one in another. And every component is, when you attach, look at them as components. Every component is just responsible for managing a piece in the DOM, and potentially with their own state. And your entire UI can be abstracted into a tree of components. So this is essentially becoming a consensus among all major mainstream JavaScript frameworks today, because almost every framework now has converged on the concept of components as the basic unit of composing your application. And a lot of them also gravitate towards the same approach of using the custom element syntax in HTML templates to serve as the placeholder for components. So when you define a component with a name sidebar, it can encapsulate its own template logic inside of it. And when you use it elsewhere, you can just declaratively nest it with other components similar to just plain HTML elements. And when you go beyond that, we also need a mechanism for data flow communication between components, because it's likely that your components need to talk to each other. And it's also likely that when a component holds some state, it needs to pass some data down to a child component. And there's a system called props, where essentially we can define custom attributes on custom elements. So these attributes allows us to bind data from the parent scope into a child component. And for child components to affect the parent scope, they can emit events similar to how native DOM elements can dispatch events. So you can listen to an event and handle, they can send a payload back, and you can act accordingly in the parent component. So we're being pretty abstract here. I don't want to really go too much into the code details, just so that we know that there is a carefully designed contract of how components should interact between each other in Vue.js. So once we have declarative rendering and components, so that should probably be enough for you to handle quite a big portion of the common usage scenarios. But in certain cases, we also want to build a real single-page application. So how many of you have built a pure single-page application here? Great. So when you build single-page applications, I'll just briefly explain the concept where instead of rendering views on the server, we will mostly use the server as an API endpoint. So your front end is going to be completely rendered by JavaScript in the browser, which means we also need to handle the problem of deep linking and mapping URLs to the correct application state. We also need to handle history management. When the user clicks the back button, things should happen correctly, and the navigation between routes. So the simplest example is when you have an app that's served at /app, you want that URL to map to a certain structure in the DOM. So this is just an extremely simple example where the app component contains a home component. And when you navigate from that URL to another URL, which is app post 1, you want to swap the home component to a post component. And the post component should be rendering the correct content based on the current ID that's contained in the URL. So Vue Router is the official library for Vue.js that implements all of this for you. It comes with a pretty straightforward API that allows you to declaratively map URLs to nested component structures and handles all the transitions and updates, navigation between them automatically. So this is necessary if you want to build an app with very snappy user experience, because there are certain types of apps that would just simply be better if you build it as a single-page app. Imagine if you have to reload the browser every time you click on a link in Gmail. That would be intolerably slow, and you can only build it as a single-page app to make the user experience acceptable. So, and beyond that, when your app grows even more in complexity, so let's say you have 5 levels of nested components, and you have like hundreds of components on the same page. And many of these components will eventually run into the problem that they need to share state. So think about if we're building Gmail, and you have the list of mails stored in memory as an array of JavaScript objects, right? So the simplest way to do it, we probably would just store it in the inbox component, the component that represents the inbox. It'll hold a list of mails. And then you implement another component, for example, a search component. So when you type in that search component, it needs to do a type-ahead filtering of all the existing mails that you have in memory. And when you do that, these two components are asking for the same data, right? It doesn't make sense to duplicate them in both places. And it doesn't make sense for either of them to actually hold that data anymore because this data needs to be shared. And when you try to just let one component own it and let other components ask for it, you are creating the problem of component communication. And in Vue 1.x, we had the system of event propagation that allows you to broadcast and dispatch events between parent and child. And we found that ended up leading to a lot of complexity because the system was coupled to the structure of your component tree. And also, event flow was very implicit. You have to essentially keep in mind how your components are pieced together in order to reason about how events flow inside your application. So we ended up learning a lot from, so in the React world, people have been doing a lot of innovations in terms of state management. And Facebook first came out with the concept of Flux, which essentially try to pull state out of all your components and manage them centrally. And then later on, the React ecosystem had converged towards the current de facto standard state management library called Redux. But the core concept is state management in front end should be centralized and predictable. These are two most important things that we want to tackle when our app gets huge. So we talked about the problem of sharing state between components just now, and the other problem that we have is unpredictable state mutations. So in Vue, you can trigger changes just by setting things. This is very convenient. This is also why it makes things very simple. And it works really well in small to medium scale applications. But imagine you have a team of like 10 developers working on the same app, and we are allowed to mutate the state anywhere in a method or in a callback. Inevitably, you would run into situations where when you are debugging the app and you cannot figure out where the line that changed this state is. So to deal with that situation, we pay the cost of, tiny extra bit of verbosity in return for predictableness. And that was so that's kind of the general design trade-off that we chose to take in a library called Vuex, which is a Flux-inspired state managed solution, but it's tailored for Vue.js. We put all state that needs to be shared across multiple components, we pull them into a centralized store. And so the store holds the state, which is the purple circle down here. And components will pull state out of the store using just plain computed properties. Because the store itself is also using the same reactivity system that Vue uses. So when you pull state out of the store, Vue keeps track of the dependencies. So whenever the store state changes, the components will just automatically render correctly. And for the components to mutate the state in the store, they cannot just access the state and change it any way they like. They have to do so by calling something called actions. So actions is actually a very optional concept in Vuex. So we can kind of skip that for now and focus on the part called mutations. So mutations are essentially explicitly listed functions that mutates the state in your store. So this may look tedious when you're just changing like a single property and you need to like declare an extra function just to do it. The benefits you get in return is that when you look at a store definition, you will see this state shape, and you will see all the mutations, and you instantly know all the possible ways that the state could possibly change. And when you're debugging an application, when you see something change, you can just reason about how it changed by looking at the list of mutations that was triggered, instead of searching around all the possible places where the state could have changed. And using this, we also get the opportunity to hook into the log of mutations. So we have the dev tool, which is the official Vue dev tool that could, keep track of all the things that happened, and we'll see how the UI of it for later. But for now, we just know that the log of mutations is very useful in building developer tools. And so that's it for Vuex. So after we have all the core libraries that helps us, complete a library stack for building large-scale applications, then comes the problem build system and development experience. So if you are not using a build system today, you're probably intimidated by how complex they are, right? So Laravel Elixir is doing a great job in hiding a lot of these configuration details and just exposing a very simple-to-use API. And Vue wants to do that too, and we want to make sure that you don't have to jump through tons of hoops just to be able to get some of the great benefits of modern developer tooling. So we have this concept called a single-file Vue component. This might be too small for you to see, but each component consists of 3 parts: template, script, and the style tag. So this looks just like HTML, but we give it a special extension so that we get a proper syntax highlighting. And the difference between a single file Vue component and a normal HTML file is that you can use arbitrary preprocessors in each of those tags. So notice that the template tag has an attribute called len equals jade. So that allows you to use a different templating language that compiles down to HTML. And in the script, we're using, by default, it uses Babel to compile your JavaScript from ES 2015 into ES5 that's supported down to IE9. And in the style tag, you can just use len equals sass to use sass. And you can also make the CSS strictly scoped to the current component by adding the scoped attribute. So when you use scoped CSS, it makes sure your CSS rules are local to this component only, and you don't need to worry about selectors accidentally polluting the styles of another component. And all of this looks very similar to web components, which is something pretty different. So Polymer is the library Google developed that's built on top of web components. Our primary difference is that Vue's component system is built around module bundler tooling. So you would have to use this with either Webpack or Browserify. The benefits when you use that is all this code is eventually compiled down to a JavaScript module. So when you import, so notice that we are exporting the component definition in the script section. So what you can do is you can import this file as a JavaScript module in another JavaScript file. When you import it, you just get the object with the CSS and the template already compiled and handled for you. And that makes it that you can have these components coexist with your normal JavaScript files, and your whole app is just a coherent bundle. And there are many other extra benefits. So we already talked about imported as ES 2015 module, the collocation of template logic and style. Some people are concerned about the separation of concern. And my opinion is that separation by language is not a separation of concern. Separation of concern in a front-end application is the separation of by components. The component is the basic unit of concern that you need to worry about. And the template, the script, and the style are implementation details that inherently belong together when you're thinking in terms of components. And it just makes it much easier so that because you don't have to jump between contexts. You don't have to jump between a template file back to JavaScript and then back to CSS and trying to figure out how they affect each other. because things in the same file, they belong to the same component. And you can just use what you already know, HTML, CSS, JavaScript, or any preprocessors that you like. And we have scoped CSS. One thing to note is we also support hot reloading the component, which means when you edit the component, the page doesn't reload. Only the components that has changed will be basically time travel into the state that it should be in. It's a fancy feature that we don't have an official integration with Laravel yet. It would be kind of a headache to set up, but if you use the Vue CLI, which is a scaffolding tool that handles a lot of these tooling setups for you, you get hot reloading out of the box. But using Vue CLI entails that you are going toward a more decoupled code organization pattern where you probably have your backend app in one repository and your front-end app in another. But starting Laravel 5.3, we now have official integration where you can just have Vue components in your app out of the box. And that the default integration is using the latest 1.0.26, I believe. But I also just wrote a plugin yesterday that allows you to use Vue 2.0 in a 5.3 Laravel application. So that's the name of the repository, and usage is almost exactly the same with the 1.x plugin. You just install it, require it in your gulp file, and you're good to go. So this is the DevTool that we talked about. The official Chrome DevTools extension allows you to inspect the component tree of your application in real time. Any change is reflected. For example, if you edit the state of edit an input box, you'll see the value updating real time, and you can inspect the state of each component, and you can click to go to their actual DOM node in the Chrome DOM inspector, and you can send the component instance to the console to play with it. So you can call a method, assert some state, basically allows you to debug whatever that's happening. And remember, we talked about Vuex has the mutation log, which allows us to record everything that's happening in your app, and you can just click between them to do the time travel debugging. You can rewind the state, revert it, or reset the state, or what's better, it's not shown here, but in the latest version of the DevTool, you can export the current state of your application as a JSON file, send it to another developer, and they can import it and have the app travel to the state that you are looking at, so we can identify problems faster. So, Vue 2.0. We announced it back in April, and it's been quite a few months of a lot of work going on, and I'm happy to announce that 2.0 is now in RC. It's actually already at RC3. I published the RC at Laracon US, and so that was how many days ago? I can't actually remember, but it's actually, the code itself is really stable now, so you're welcome to jump in. The link goes to a work-in-progress version of the documentation. And so the real work left is documentation. So once we have the documentation ready, 2.0 will be out. And some highlights in 2.0. It's even leaner than 1. In version 1, we have the whole thing at around 26 kilobytes minified plus gzipped. And in 2.0, we have the runtime-only build, which allows you to get rid of the compiling phase. If you're using the build tool, because the build tool, the Vue loader and Browserify and Webpack will pre-compile the templates for you, so you don't need the compiling parts in the browser anymore. So we can just throw that away, and the runtime-only build is 15.7K minified plus gzipped. And even if we include the compiler, it's still at like 22 something, so that's still lighter than version 1. And it's even faster. So in the benchmark that we talked about earlier, 1.x is about 2 times slower than vanilla JavaScript, and 2.0 is like close to bare metal. So huge improvement, and in terms of initial rendering, the improvements is even bigger. So some of you might know that in 2.0 we switched the rendering mechanism to use a virtual DOM. So for those of you who don't know, virtual DOM is first pioneered by React, which essentially we're generating a in-memory representation of the DOM shape, and then let the framework do the diffing to morph the DOM into its desired shape. And in 2.0, we're still keeping the familiar templates, but under the hood, what we're doing is compiling these templates into render functions. So render functions are just plain JavaScript functions that return virtual DOM nodes. These virtual DOM nodes are a memory representation of a real DOM node, and what this entails is, in 2.0, we give you the ability to skip the template compilation and drop down directly to the render function layer. So you can manually write render functions if you want, which means you have the full power of JavaScript to apply logic that's sometimes just not feasible in templates. Because templates are designed to be with the constraints because it prioritizes semantics and readability at the same time sacrificing some programmatic power. But sometimes there are just certain things you feel you would feel constrained by the template syntax, and you would hope that what if I could just use JavaScript to express this logic? And when that happens, in 2.0 you can selectively drop down to render functions and just do that in JavaScript. And this gives rise to a lot of possibilities that you can write very complex components that have great use. A great example is the router components and the transition components in 2.0 are all written using render functions because it involves a lot of logic. 2.0 also comes with server-side rendering. This might be less exciting for Laravel developers because it requires a Node.js runtime, but we'll definitely look at the possibility of just having a node process serving as a service process that just runs in the background and just talk to your Laravel application. If you opt to use this, in a lot of cases, if your app is not strictly SEO sensitive, you probably don't even need it. And in addition, we also have native rendering. So there is this project called Weeks, which is maintained by Alibaba Group, which is one of the biggest tech companies in China. And essentially, this is equivalent to React Native, which allows you to write native apps on iOS and Android using Vue syntax. So it's possible in the future that we have universal Vue components where it can just work equally on, you can use it for a web project, for an Android project, for an iOS project, and all served by the same API backend. So there is a work in progress official collaboration between me and the Weeks team. So we already have a working branch which uses the latest Vue 2.0 as its official runtime. So and eventually their plan is to just switch using Vue itself as the JavaScript runtime, and they will be responsible for handling all the native rendering work. So get started. This link points to a different one, which is a list of resources for you to get started with 2.0 today. And that's all I have. Thank you.